Go away.
All right, we can get started. All right, the respiratory system. There's the classic picture of a man with his head turned to the side. You can see the anatomy. Well, anyways, the main function is gas exchange. Now, the first lecture is anatomy. The second lecture is the mechanics of breathing. The third lecture is gas exchange. But for this system, to give you an overview, kind of elaborate on the main function. This system is kind of like a mechanical pump. We call it pulmonary ventilation. Ventilation is breathing. And you take a breath in, that's inspiration. You take a breath out, that's expiration. So to understand that, you have to kind of look at the anatomy. You can see the lungs, but then they show the chest wall. And that's important because actually the lung wall is stuck to the chest wall. And then you look at the bottom, it's attached to the diaphragm. The lungs are stuck to chest wall and diaphragm. So the thing is, when your chest wall expands and your diaphragm contracts and flattens, when you take a breath in, your thoracic cavity increases in volume. So when you increase thoracic volume, as a result of the chest expanding, because the lungs are stuck to the chest, you're expanding the lungs with the chest. And so when you do that, you're actually decreasing the pressure inside the little pulmonary spaces called the alveolar spaces. So I'm going to say you decrease intrapulmonary pressure. Increase the volume, you decrease the pressure of the gas molecules inside the lung, because the gas molecules have more space to bounce around when you increase the volume. So when you decrease the pressure, that creates a little vacuum that draws air to equilibrium. So this decrease in pressure draws air into lungs. So, is that a breath in or a breath out? It's a breath in. So how do you breathe out? Well, it's just the reverse. When you exhale, the chest wall collapses. That decreases the thoracic volume, and that increases the intrapulmonary pressure Then you have a gradient, so their air is kind of pushed out of the lungs. So they say that the lungs are like an air pump because you're always drawing air in and pushing air out. And well, that's one thing. That's pulmonary ventilation. So that's just the act of breathing. But by breathing, you're ventilating what are called the alveolar spaces. So that's like point number 2. You ventilate the alveolar spaces. Okay, these are the tiny little air sacs inside the lungs that you can't see in this picture, obviously. But you have something like as many as 600 million of these microscopic spaces. Anywhere from 300 to 600 million. And then so that's a lot of spaces, and in each one of those spaces, if I were just to kind of draw it like our, this is usually how we symbolize the respiratory system. You draw fresh air into this flask, and you fill this space with fresh air. Okay. And then what happens is, when you ventilate the alveolar spaces, this system, it provides a lot of surface area for gas exchange, and we call that the respiratory membrane. Provides lots of surface area for gas exchange. Respiratory membrane is what we call it. Well, okay, you got the air there, that's the alveolar space, but then I have to draw a blood vessel. Let's see here. Now you know pulmonary circulation. When blood comes in, it's oxygen poor, right? The pulmonary arteries pump it to the lungs to get oxygen. So as it passes by, it's going to pick up oxygen. And that capillary is kind of sealed to the alveolar space. A little connective tissue. It's a very thin membrane. I kind of exaggerated it, but I mean, I guess this interaction right here is symbolic of the respiratory membrane. It's just a membrane that consists of 3 layers. I'll define it more carefully later, but anyways, that's where gas exchange occurs. And blood leaves oxygen rich. And it's the job of the pulmonary veins to collect this oxygenated blood to return it to the left side of the heart. Okay, so that's the key thing, respiratory membrane. Okay, so you got breathing, you got respiratory membrane. And then so the third thing we learn is that this system, it uses the circulatory system to transport the gases over long distances. That'll be my third point. Number 3 uses circulatory system to transport gases. And we're always just talking about O2 CO2. Now, we already know that the O2 is mostly transported bound to hemoglobin. Okay. And actually, what you want to do is you want to use this system to get rid of CO2. So, at the lungs, you want the blood to pick up O2 from the fresh air you breathe, and you want to expire CO2. Think of it as a waste product you want to get rid of. And so in the blood coming in, you want CO2 to leave and be breathed out. So that's kind of the exchange that occurs at the lungs, and we call that external respiration, gas exchange at the lung. So then gas exchange anywhere else in the peripheral tissues is called internal respiration. Gas exchange at what's called the peripheral tissues. Because the blood leaving the lungs is now oxygenated. Okay? So then if I were to draw, like, you know, some generic cells in the body, symbolizing peripheral tissues, where you have low O2 and CO2 is building up. It's a metabolic waste product. You have to kind of exchange with that now. So then blood coming in, the gradient is such that O2 will now leave the blood, right? And it'll pick up the CO2. It's a gas exchange. It's just gas molecules following their concentration gradients. That's all it is. So then the CO2 is picked up. So that blood leaving the peripheral tissues is O2 poor and CO2 rich. So it's just kind of like the reverse. So that's gas exchange. And I'll be more detailed on that in the last lecture. But let's start to look at this picture now, the anatomy. Three things we can define. So let's go conducting zone versus respiratory zone. This is the zone where you can have gas exchange. The structures have that ability. Whatever structure we're talking about, we'll get into it, but you got to have those microscopic alveolar spaces. Alveolar spaces. Alveolar is a word that means a tiny little air sac. Okay, well anyways, the conducting zone just conducts the fresh air. There's no gas exchange. That's why it's called the conducting zone. Conducts fresh air. No gas exchange. The conducting zone begins, we don't teach the mouth as part of the airway, although you can breathe through your mouth. We teach that as the food way. The airway is basic. Well, I'll be basic first. You got the nasal cavities. have the throat, the pharynx. You have the larynx. And usually the larynx is your throat, your voice box, and it's in your anterior neck. But these are considered the upper respiratory tract. Just give you an overview, and like if you get a cold or sore throat, it's kind of like these structures that are affected. Then you have the trachea. And you can see that in the picture. You have one trachea. When people say the airway, they're usually referring to that, okay? Because that will deliver the fresh air to both of your lungs. And then the airway divides. You can even see the first division at the carina. Divides right there. And you have one airway for each lung. We'll get into how the airway divides, but the larger airways that are that conduct the fresh air are called bronchi. Plural, bronchus, singular. Now these larger airways are good because they're always open, because they have these cartilage. Cartilage is stiff. It keeps the airways open or patent because you're always ventilating air through it. That could collapse, like if you were to suck air through a paper straw and the paper straw collapses. Well, anyways, your airways don't collapse because the cartilage keeps airways patent, which means open. Now, when you get to the smaller and smaller and smaller airways, they're called bronchioles. Now, the difference between, you can't see the smaller airways, they're deep in the lung tissue. And you can only see the first division right there, but we're going to go through all the divisions and I'll show you more pictures. But now you're deep into the lung tissue when you get to the bronchial level. And we're still considered part of the conducting zone. And there's many divisions. There's one division where it's like the last division where the bronchioles right before the respiratory zone. So there's one area where you call the bronchioles terminal bronchioles. Well, anyways, bronchioles are like arterioles. They don't have any cartilage, but they do have an increasing amount of smooth muscle. And that's important because you can control smooth muscle. You can dilate and constrict appropriately to allow airflow. And so that's an important functional thing to know, that you start to have smooth muscle at the bronchial level. But when you get to the terminal bronchioles, that's the end of the conducting zone. And then you have some bronchioles that have those tiny little air sacs, and you call them respiratory bronchioles. And you have alveolar sacs. And those will lead to your little alveolar spaces. And that's pretty much it. The respiratory zone is a dead end. You bring the air in, you have gas exchange, and you breathe the air back out. So the blood keeps going round and round, the circulation. Right? The air just goes in and out. Well, anyways, to teach the anatomy a little better, we got to look at more pictures besides this one. So let's start with the pharynx and the nasal cavities. So there's I like this picture next to this picture because you have a more accurate illustration next to the diagram of the pharynx. Let's see, there's one that makes this. Well, when you first breathe in, let's not forget our nose. External nares is what we call it. Your nose with the hair follicles. Now this right here is actually called the posterior aspect of your nasal cavities. Well, let's not skip the nasal cavities. The nasal cavities, you can't see it here because they have the septum, but these are the conchae, superior, middle, and inferior conchae inside both nasal cavities. And that's important to note. So once you take a breath in, you have your nasal cavities. They're separated by bony cartilaginous septum. Now the bony part you're supposed to know that's part of it's vomer, part of it's the perpendicular plate of ethmoid. You can go back and look that up if you want. But there's the cartilaginous part as well. The nasal cavities have conchae. And those are described as like these little air turbinates. And they'll help to, when you breathe air in, they'll kind of like break up the airflow and start to warm and humidify air. Slow, warm, maybe not so much humidify, but at least slow and warm airflow. Air does get humidified as it gets deep into the lung tissue. But the conchae, after the conchae, then you kind of go into the you exit the nasal cavities through the internal nares and you get into the pharynx. So the pharynx is your throat, and it's divided into the naso-oral-laryngeal pharynx. Okay, so from top to bottom, nasopharynx. I'll pause right there. And one thing to note in the nasopharynx, well, actually a couple of things. You have this little orifice right there, and you have this little bit of lymphoid tissue. Okay, I'm going to note both of these things. Okay, that is a pharyngeal console, and this is called the orifice to the auditory tube. Tonsils are lymphoid tissue. You have a orifice to auditory tube. That goes straight to the tympanic cavity of the middle ear. Okay. So your eardrum is tympanic cavity, your auditory ossicles. You can go back and look that up if you forgot the ear lecture, but that's important to note. So your throat's connected to your ear and it's connected to your nose. So that's why they have ear, nose, and throat specialists, because, well, if they're all connected, it's how infection can spread. So know that orifice. Let's see. Then you have this right behind the oral cavity is the oral pharynx. This part colored, this orangish color. Let me continue up here. It's right behind the oral cavity. It's called oral pharynx. That shouldn't be too hard to figure out. Now, the thing is, there's a little, these like little membrane folds. Like if you look at the back of someone's mouth and you kind of see those. When you see this little down, this is soft palate. We call it the uvula. And these are called the fauces. So I'm just going to list them as structures to be aware of. Now the fauces are, I'm not going to have you identify fauces, but I pointed them out. This little bit of tissue right there, you can look in your book. There's a piece of lymphoid tissue there, your adenoids. We call them your palatine tonsil. They're in the fauces. So I'm going to list palatine tonsils under fauces. Then you have the laryngeal pharynx in green right there. Okay. Now this is kind of like a fork in the road. You want to route air down the airway, but you want to route food down the foodway. Okay, and that's kind of where it occurs at the laryngeal pharynx. Since we're talking about the airway, not the foodway, you want to be thinking about the laryngeal inlet. That's the entrance into the airway. So I'll just list that, and we'll look at another picture of it. Right there. Okay, so but let's orient ourselves. Okay, so I put this picture in. This is a posterior view. What you did, I've never done this section, but here's what I know you can do. There's a little ligament right there above C1, and if you cut that, you can separate this whole front, head and neck and throat away from the cervical vertebra. They just separate easily. There's nothing attaching them. Okay. So when you do that and you cut the throat open, the pharynx, then you can see this. And that's what we're looking at here. So here are the conchi. There's the nasal septum. So this is like the interior internal nares. And there's the uvula. There's the root of the tongue, just to orient yourself, right? So this is the epiglottis. And more on that later. But that's the laryngeal inlet. Let's do note these two little bumps or tubercles. I may have you identify those. These tubercles are created by cartilage, but when you put the mucous membrane over it, they look like little bumps. You can't see the cartilage, so let's just kind of list cuneiform and vermiculate tubercles. Maybe it's good to list them by here, because they're kind of like by the inlet, cuneiform. Tubercle, corniculate. Tubercle, and they're created by little cartilages. And let's move on. Let me get my thumb drive out of there. So now that we're in the larynx, let's talk about the cartilages of the larynx. So I want to start by looking at the same picture, but look at the picture next to it. That's usually what we have in the lab. I give you the page numbers. So you can study them at home, but if you look over there, when you're in the lab, we have a lot of larynx models, and I tend to use them all. So the larynx, what we're talking about now. There's two functions. It's your voice box. Okay? It's for voice production. But it also guards the airway. let's look at more pictures of the, we have a model that looks like this. This model is in the room. We call it the tongue larynx model. It's over there somewhere. And I like this model. But there's the laryngeal inlet. Let me see, is it over there? Oh yeah, let me get over there. Yeah, so I took some pictures to kind of line it up so you can kind of relate to that picture. And what I like about this model is you can see both tubercles right here. Boom and boom. That's the corniculate tubercle right there. See that little blue spike, little horn that's making the bump? You can't see this one here, but that's the cuneiform one. So anyways, both of those little bumps are shown well on this model. Now let's move on. Here's a side view of it. And here's another picture of the larynx. What I did was I just took this picture and I tilted it to make it match this. What we see about the larynx, it's located in the anterior neck. The posterior neck would be the cervical vertebra, but you can see the carotid running right next to the thyroid. You can see the bifurcation at the level of the superior border of the thyroid cartilage. So this is actually called the thyroid cartilage, and that's the thyroid gland that we learned about in endocrine. So that's how it got its name. So some of the laryngeal cartilages I want you to know include the thyroid cartilage and the cricoid cartilage. Laryngeal cartilages. Stiff cartilage. So the biggest one that's shaped like a shield, thyroid means shield. Thyroid cartilage. When people say voice box, that's it. That's the box. Not really a box, is it? But it has a nice shape and that little point that you can feel in your neck. Right here. Laryngeal prominence. Adam's apple. Women have it too, just not as pronounced. But laryngeal prominence is what we call it in an anatomy class. Now, look at the cartilage right below it. It's partially obscured by the thyroid, but that's it isolated. That's the cricoid. It's shaped like a ring. That's the band of a ring. It's like a class ring, right? To be able to identify the cricoid cartilage. It's not on your study list, but it's good to know. This ligament right there, that's kind of where, if your airway has is blocked somehow, that's how they can bypass it. And they have to make a decision and stick something down there. But it's between cricoid and thyroid. So here are different views of the larynx, a superior and a posterior view. And so from let's start with the superior view. Look how big your voice box is, your thyroid cartilage. What makes it a voice box? These vocal ligaments right there. So look at the posterior view. You see these paired cartilages from the superior and the posterior view. Let's note that. Those are paired arytenoid cartilages. There's two of them. So I'll say paired. Paired arytenoid cartilages. So vocal ligaments run from thyroid to arytenoid cartilages, as you can see from that picture. Attached to thyroid, arytenoid cartilages. When you form speech, sounds, you're vibrating the vocal ligaments. They make kind of a V. But notice that those arytenoid cartilages, they can pivot. So they're showing you right there. They pivot to kind of open and close the space between them. That's called the glottis. Vocal ligaments. Open's important. That's when you take a breath in. That's the only way you can get air in. They got to be open when you breathe in. Inspire air. Okay. So open, inspire air. When that space between the vocal ligaments closes, that's usually when you take a breath out, and that's how you force air to whistle through this slit when they close, and that produces speech. Expire, and speak. So they open and close, and anyways, the space between vocal ligaments is called the glottis. When it's open, glottis, space between. I don't think it's labeled there. It's labeled on another figure for sure. Let's just note it now. Glottis, space between vocal ligaments. That's important. That could get blocked when you're choking. The glottis is very important. One way you guard the airway, which is the glottis, this space here, the space between vocal ligaments. When you swallow food, you want this to cover it. This is a bendable epiglottic cartilage. It folds down over the glottis when you swallow food to guard the airway. So it's called the epiglottis. So no. Glottis. Covers glottis during swallowing. Notice the pararytenoids, right on top of them are those little spikes. And those are your little corniculate cartilages. So I already noted them as tubercles, but they're also cartilages. So let's kind of just write down paired corniculate cartilages. I'll just put them under paired arytenoid cartilages since they're both paired. Paired corniculate. Something that has that corn, that means horn-shaped corniculate cartilages. List them next to the arytenoids because they're closely associated. They're right on top. It's like a little horn right on top of the arytenoid. Arytenoid means pitcher-shaped. I never thought it looked like a pitcher. Well, anyways, let's look at more pictures here. Here's that side view of the neck. Now, we cut right through the larynx in this picture. When we look at the comparable view of the cartilage cut, you can see all the cartilages that we've just listed on the board. And this one's your big thyroid cartilage. There's your cricoid. There's a little pitcher, the arytenoid cartilage, and your little horn, corniculate. Now we see two ligaments. The bottom one is the vocal ligament. The top one is the vestibular ligament. That's what I want you to know. Bottom, vocal, top, vestibular ligaments. So let's kind of get into this whole ligament thing. Now, let's start with the one I already listed, vocal ligament. That's your true vocal cord. Now, when you put membrane over it, it creates a fold. So sometimes they call it your vocal fold or true vocal fold. Vocal fold. You can call it any of those three things and you'll get it right. Okay, I mean, it's, right there is just a ligament, but when you put the skin over it, they look like lips. But that bottom lip, that's your true vocal fold or vocal cord. Okay. The top one, that's your vestibular ligament. That's your false vocal cord, doesn't produce any sound. So you call a false vocal cord or vestibular fold. It's the top one. Now, it's hard to tell from this picture, but it kind of makes a little shelf over the airway, thus protecting it. Yeah, I'll put that. This little fold helps protect airway a little bit. It doesn't produce sound. All right, let's move on. This picture, there's a picture of the corniculate cartilage and the arytenoid cartilage isolated. Okay. You can see how they're associated with those ligaments. Here's kind of the view of the laryngoscope. I've seen paramedic students practice intubating on cadavers. What they're doing is they're looking for this little whitish V. It's hard to view, but if you can see that, that's where you stick the tube in, basically, when you're trying to restore air. Here it is with just the laryngeal cartilages, but you're looking for that little white V. And that's the entrance into the trachea, your airway there. So what I did was I took a picture of the model, right? This model. And yeah, just like that. And I was just trying to look for those little whitish structure. What are those? Identify. Vocal ligaments or vocal fold, true vocal cord, whatever you want to call it. This picture right here, the whitish ones are the true vocal cords. You see this little fold right next to it? That's vestibular. Do you see how it kind of protects the airway? Like if something falls on it, but it falls like that, it's like a little shelf. So in a way, I'm sure that would really irritate you and you gag it out. So in a way, it hopefully doesn't fall that way. Hopefully it falls to the side. That's why I say it kind of sort of helps guard the airway. What would really help is if you like chew your food. Not swallow, take big bites and swallow and choke. And you know, the sound of choking is you can make no sound. So yeah, if you can hear someone kind of gasping or coughing, they'll probably get it out. But if they're making no sound, the airway is completely blocked. So there's the glottis closed. Air whistles through, that produces sound. Here's a picture of them in your book. I thought it was a good picture. It kind of shows here how the true vocal cord and the false vocal cord, there's a bit of a shelf there to help guard the airway. Again, this is this model again. Well, there's a real picture of open and closed vocal cords. Let me just get all my points up here. So, speaking is the release of, intermittent release of exhale there, and you open and close the glottis when you do that. When you breathe in, you know, vocal cords open, the air rushes in, and when you exhale, the vocal cords close, air is forced to whistle through a slit, vibrating the vocal cords, producing sound. And pitch is determined by the length and tension of the vocal cords. The loudness depends upon force at which air rushes across the vocal cords, and the pharynx, nasal cavities, they resonate, they amplify, enhance the sound quality. And of course, sound is shaped by lips and tongues and soft palate. I don't want to get into too much detail, but we should learn at least a couple of muscles of the larynx, one in the front and one in the back, just so you can kind of appreciate how they can control vocal cords. So in addition to the cartilages that you have to identify, there are two laryngeal muscles. One on the front, one on the back. Well, one kind of in the front on the side, that's two heads. That's the crippled thyroid muscle. Well, the one on the back is called posterior cricoarytenoid. All right, the innervation of the crickled thyroid is the superior laryngeal nerve, external branch. I'll just say superior laryngeal nerve. These are all branches of vagus nerve, okay? Superior. It's a branch of the vagus nerve, and the reason why I put this picture in, it's different on the right and the left side. Notice on the left side, it's like a part of it goes down and comes up. This is called the recurrent laryngeal, which gives rise to the superior laryngeal nerve. But this recurrent laryngeal, I'll put this as a side note, it goes under the aortic arch on the left side. Recurrent laryngeal. I'll say it passes under the aortic arch. That's clinically significant. If someone presents with a hoarse voice, there could be an aneurysm right there because it's pinching that nerve. So that's worth putting it on your list of things to know. Because an aortic aneurysm, that's an emergency surgery, right? You gotta get to that thing before it bursts. Okay, well anyways, back to the crippled thyroid. Well, here's another model. I point to the screw because that's the hinge where it pivots. When this muscle contracts, it makes the thyroid pivot forward. So it's good to play with that functional larynx and kind of pull on it. And if you look on the inside, you would see that it tenses the vocal cords. That's its function. So back to the crippled thyroid, tenses vocal cords. That's its action. You know, when you like make a higher pitched noise, it's increasing the tension of the vocal cords. All right. Well, the other picture here, that's the posterior cricoarytenoid muscle. That's innervated by, again, a branch of the recurrent laryngeal nerve, but let's just call it the inferior laryngeal nerve. And its job is to abduct the vocal cords. So I'm pulling on this string on a functional larynx model. It makes the arytenoids pivot, and you can kind of see how it abducts the vocal cords there in that picture. That's important. If you paralyze that muscle, you're going to have trouble breathing because you can't open the glottis. Here's the model showing you both nerves, superior and inferior laryngeal nerves. That's a good model that shows it there. One thing about the larynx that's important to note is, for a functional thing, is the Valsalva's maneuver, which is straining against a closed glottis. So we do it instinctively, like when you lift a heavy box and you grunt, that kind of thing. What you're doing is you're temporarily holding air by closing the glottis, and you make your trunk like a splint. It causes an increase in intra-abdominal pressure when the ab muscles contract. It helps, like, when you do that when you kind of go number 2, you empty the rectum, you stabilize your trunk when you lift heavy loads. It increases blood flow to the head. I know this is one thing they do to fighter pilots. They make them do this Valsalva's maneuver, like during the G-forces, because the G-forces, you're flying a jet. When you kind of like dip the nose of the jet down, you're flying downwards. The G-force down is so strong that the heart can't pump blood up to the head. You black out. So to train against that, they have the flight suits, but they also increase the musculature around the head neck area, and they have them do this Valsalva's maneuver, and it prevents them from blacking out. You also do it when you equalize middle air pressure, right? You make your ears pop when you drive up to the mountains. Let's see here. Okay, well anyways, I'm done with the larynx. And the next part of the airway is the trachea. So you can feel where your larynx is in your neck, right? Because that's the laryngeal cartilage, the laryngeal prominence. And then right below that is the trachea, and it's not very long. And I can feel my laryngeal cartilage. The trachea ends just below the sternal angle, and I can feel my manubrium right there at the top of it. So if I feel just below that, where my microphone is, right around there, the trachea is only like from there to there. And it's only like 4 inches long. It's a little less than an inch in diameter. So another reason why I like this model is it kind of approximates what the trachea can accommodate, maybe 1 finger. Okay. Your main airway. 4 inches in length. Less than 1 inch in diameter. How many do you have? 1. You have 1 airway. It goes straight to your lungs. It divides many times. Well, anyways, before it divides, it's just the trachea. So, in this posterior view here, the trachea is from there to there. Okay. Now, if you were to cut it like they do, they cut it right below the larynx, right there, and you can kind of see how it's related to the foodway, the esophagus. And you can see if you cut right through one of those cartilage rings, You can kind of see how it's like shaped like a horseshoe. We say they're C-shaped. Contains C-shaped cartilage rings. And they basically keep the airway open. Okay, I already said that. But what we can see here is that the tracheal wall is extensive. There's a mucosa, submucosa, and an adventitia. I want you to know what that looks like under the microscope. So here's a tracheal wall under a low magnification. Okay. So let me have space. The tracheal wall, the mucosa. We have to go to a high mag to see it. On this picture, why don't you guess, top or bottom? What do you think the mucosa is on this one? Top. And let's go medium magnification, high mag. You can see this is from here to here, mucosa. I want you to know the epithelium. So this is conducting airway, right? The job of the conducting airway, no gas exchange. You have a nice thick epithelium to help warm, humidify air. You also want to catch debris. So this is a good mucous membrane right there. But what it's called mucosa, right? So you know it's a mucous membrane. So that epithelium is a ciliated, pseudostratified columnar ET. Ciliated. Pseudostratified columnar ET with goblet cells. The goblet cells help make it a mucous membrane. So I'm going to point to one in case you're not used to identifying them. They're usually clear-ish. They contain mucin, which doesn't take up a stain. Little single one-cell glands that secrete mucus. And is underlined with this lamina propria, this connective tissue. It's like a basement membrane called the lamina propria. A loose CT. Well, this from here to here, let's go back. So from here to here, medium magnification, higher magnification, here to here. It's considered the submucosa. And all of these cuboidal epithelial things, those are glands. So these are called mucus glands or seromucus glands. Mucus. So submucosa. It's got the mucus glands. And all this mucus, it has to be secreted onto the surface. So you can't see it, but each of these is going to have a duct to the surface. See how it kind of like divots like that? That's not an accident. That's where one of these glands is like got a duct to the surface. Yeah, anywhere you see like a little divot there, or maybe there, one of these glands, they kind of like all lead to the surface somehow to make this a very effective mucous membrane. Here's a picture I like because it actually shows going all the way to the surface. Okay, so the seromucus glands have that function. There's just another picture of it. Let's go back to this picture here. All of this from here to here is adventitia, but really all I have you ever identify are these. These are cut tracheal rings. Okay, in the adventitia. Well, they're tracheal rings, but in terms of histology, you need to identify them as hyaline cartilage. something called a mucus escalator. Let me cue something up real quick. Okay, hold on a second. It's right here. This is an actual footage of mucus of the top of the mucosa. Let me turn the lights off so you can see it better. All I wanted you to see is that there's no sound, but I just want to describe it to you. You see those like dark spots moving one direction? These dark spots move in one direction. This is called the mucus escalator function. So when you breathe in, you can watch the whole video if you want. Maybe I'll share the link later. When you breathe in, air and debris is caught in your trachea, and what it does is it moves debris up and out. So that's the action of the cilia and the mucus working together to get debris up and out of your lungs. So it's very important. And smoker's cough is smoker's cough because the cigarette smoke, it kills the cilia. So let me go back here. But because epithelial tissue is highly regenerative, if you're able to quit smoking, you can get the mucus escalator back because the epithelium will regenerate. So I have a picture of it here, but I think the video is better. Without the mucus escalator, your cough is very unproductive because you can't get it up and out. All right. Okay, I think it's a good spot for a break. Let's talk about the bronchial tree when we come back.